Ready to take a deep dive? We've got a fascinating collection of research articles from arXiv. We're talking breakthroughs and how AI and sound are changing everything.
It's incredible. From diagnosing diseases to, even composing music, they're using sound in ways we never even imagined before.
Let's start with something that could have a massive impact: early Parkinson's detection.
Oh yeah, that's a big one. One of these papers describes a system that analyzes voice recordings to actually predict someone's UPDRS score.
The Unified Parkinson's Disease Rating Scale.
Exactly. And what's really amazing? It all comes down to something we do every single day, talking.
So by analyzing how someone's voice changes over time.
The AI can actually pick up on early warning signs of Parkinson's, the kinds of things that might be too subtle for us to hear.
And they're doing this with an enhanced long short-term memory network.
An LSTM, yep. Perfect for analyzing these kinds of data sequences, like the way someone's voice changes over time.
It even has this attention mechanism built in.
Oh yeah, it helps the network zero in on the most relevant parts of the voice signal. It's kind of like a spotlight, highlighting the specific features that are really indicative of Parkinson's.
That's pretty clever. It looks like they also use data augmentation.
Definitely. And feature selection, too. They really wanted to make sure that model was as accurate as possible.
It's amazing to see how researchers are pushing the boundaries of what's possible with sound and AI.
Absolutely. Early diagnosis can make a world of difference for people with Parkinson's. This could really improve lives.
Now let's switch gears a bit. One of the articles explores this fascinating concept called token synth.
Ah, yes, token synth. It's a neural synthesizer. Basically, it uses these things called tokens, think of them like musical building blocks, to actually recreate the sound of any instrument.
So instead of like the traditional sampling methods,
You could describe the sound you want with words. Token synth would just generate it for you.
so I could type in, I don't know, a flute that sounds like wind chimes?
Exactly, and token synth would bring that to life. It's pretty wild what this could mean for music composition.
Limitless possibilities. This same article also mentions using algorithms to recreate cicada calls.
Oh, that's a fun one. Bioacoustics in action. They managed to recreate the chirping of the Hyalessa maculaticalis cicada.
And they didn't just capture the sound.
No, they actually modeled the physical structure of the cicada's sound-producing organs to make the sound as real as possible.
That's a whole other level of detail. Now, shifting gears again, one article tackles a pretty big question. Are musical emotions universal?
Or are they shaped by our culture? It's a debate that's been going on forever.
And this study gathered popular music from Brazil, the US, and South Korea.
A real global mix. They asked people in each country to describe the emotions they felt while listening, using their own words.
So did they find any common ground across these different cultures?
Well, some emotions, the high energy ones, the positive ones, those were pretty consistent. But a lot of them, they were much more nuanced. It really depended on the culture.
It makes you think about how our cultural backgrounds really shape the way we experience music.
Absolutely. What sounds joyful in one culture could be something completely different in another. It's a good reminder that even something as universal as music, well, it's still seen through our own cultural lens.
Now, let's talk about hearing health. One article talks about using machine learning to identify people at risk of hearing loss.
That's huge. Hearing loss is a widespread problem. Early intervention could make a world of difference.
So they're basically feeding all sorts of factors into these models, right?
Things like age, exposure to loud noises, medical history. It's like putting together a puzzle.
And they're using this framework called Fedora.
Exactly. Feature elimination for data reduction and optimization algorithm. It helps make sure the model only focuses on the most important information.
So this could lead to, like, more accessible hearing loss screenings, catching those problems early on.
Exactly. And that could mean earlier intervention, better outcomes for people. It's the power of AI working with sound analysis.
Now, there's another fascinating development called Speech Compass. Have you heard of it?
Oh yeah, it's all about enhancing mobile captioning. That thing that transcribes spoken words into text? It's adding a really cool element.
Which is?
Spatial awareness. Using multiple microphones, it can actually figure out where each speaker is in a conversation.
So you wouldn't just see the text on your phone. You'd know who was saying what, even in a crowded room.
Exactly. Game changer, especially for people with hearing impairments.
It's almost like a compass guiding you through a conversation.
And you know what? They didn't just stop at developing the tech. They did a ton of user testing, too, to make sure it really works for the people who need it.
I love that. It's all about making technology work for everyone. Speaking of which, one article delves into quantum computing.
Yeah, quantum computing for assessing dysphonia. It's a condition that affects the quality of someone's voice, hoarseness, strained speech.
And quantum computers, how are they helping with this?
Well, they're fundamentally different from our regular computers. They use quantum mechanics to do calculations, which is perfect for certain types of problems.
So they're analyzing voice data with these quantum computers?
Yep, and they've developed something called convolutional neural networks, or QNNs for short. They're like a quantum-boosted version of the neural networks we normally use for audio processing.
And are these QNNs actually better than the traditional methods?
So far, it looks like they are. They're more accurate, especially when we don't have a lot of data to work with, which happens a lot with dysphonia diagnosis.
It's exciting to see how this new field, quantum computing, is already making waves in healthcare.
Definitely still early days, but the potential is huge. It could revolutionize healthcare as we know it.
Absolutely. Now, let's talk about this incredible resource that could help researchers studying dysarthria. It's called the Chinese Dysarthria Speech Database.
That's a big one. They've collected over 133 hours of speech recordings from 44 different speakers with dysarthria.
Dysarthria being a condition that affects the muscles involved in speech.
Right, it can make it really difficult to articulate words clearly.
And this database, how will it help?
Well, it'll allow researchers to develop more accurate speech recognition systems that is specifically designed for people with dysarthria.
So instead of using general systems that might not work as well.
We could have systems that truly understand the nuances of dysarthric speech. Think of how much easier communication could be.
It's all about creating a more inclusive world, using technology to break down those communication barriers.
Exactly. And speaking of pushing boundaries, let's talk about MDS-Gen.
MDS-Gen.
It's a brand new framework for generating sound from visual cues. Basically, you give it a video and it creates a soundscape to go with it.
So like an AI sound effects artist.
It goes even further than that. It can generate sounds for all sorts of things, from video games to art installations, even personalized soundscapes.
Wow. What's so different about MDS-Gen compared to what we had before?
They really focused on efficiency and scalability. It's much more practical to use than older systems, which often needed tons of computing power.
So it opens up these possibilities for creators who might not have all the fancy equipment.
Exactly. It's like democratizing sound creation, letting more people experiment with sound in new ways.
I love that. Now, switching gears to the natural world, we've got an article about bird calls.
The nocturnal bird migration dataset. It's amazing. Bird enthusiasts all across Europe helped collect and annotate these recordings.
So a massive library of bird sounds, but how does this help us understand bird migration?
Well, with over 13,000 vocalizations from 117 different species, scientists can study migration in a whole new level of detail.
And they're training deep learning models to automatically identify different species?
Exactly. No more listening to hours of recordings manually. AI can analyze those sounds and tell us all sorts of things about bird populations and their movements.
It's like having a digital ear tuned to the symphony of nature. Now let's talk about MT2KD.
MT2KD, that's a game changer. It's a general-purpose encoder for both speech and audio.
So it can do it all.
Pretty much. Speech recognition, audio tagging, speaker verification, all in one system.
So instead of needing separate models for each task,
You've got one that can handle it all. It could make audio applications so much easier to develop.
that's incredible. How did they manage to create something so versatile?
They used a really clever combination of knowledge distillation and multitask learning.
So this model is both simpler and more powerful.
It really seems that way. And you know what? It could pave the way for even smarter and more adaptable audio systems.
That's exciting. Speaking of exciting, one article explores a new approach to speech synthesis: continuous autoregressive modeling.
Oh, yeah, that's a good one. They're trying to create synthetic speech that sounds even more natural, more expressive.
So how's it different from the traditional methods?
Well, traditional methods usually break down speech into these little chunks, these tokens, and then try to piece them back together. It often ends up sounding a bit robotic.
Right, it lacks that natural flow.
Exactly. Continuous autoregressive modeling, on the other hand, it treats speech as one continuous flow of information.
So it's more like the way we actually speak.
Exactly. By using these continuous speech representations, they're able to capture all those subtle nuances of human speech that the other methods miss.
And they're using a technique called stochastic monotonic alignment.
Yep. It helps to make sure that the synthesized speech flows smoothly and naturally, no more awkward pauses or jumps between words.
It's incredible how they're getting closer and closer to creating a synthetic speech that sounds truly human.
And you know what? Their model actually beat the state-of-the-art Valley model.
No way. That's impressive. And they did it using fewer parameters.
Yep, more efficient too.
It's a huge step forward in speech synthesis. But with this kind of technology, we have to talk about how to tell real speech from synthetic speech, right?
Absolutely. That's where the Shifty Speech benchmark comes in.
They're really putting these synthetic speech detectors through their paces. What all did they include in this benchmark?
Everything they could think of. Different languages, accents, emotions. They even added background noise, different recording environments, all kinds of microphones.
It's like they threw the whole world of sound at these
They
detectors.
wanted to see how well they'd hold up in the real world with all its chaos.
Now, last but not least, there's a paper on visual-based spatial audio generation.
Ah, creating a truly immersive experience.
It's all about using visual cues from videos to create spatial audio.
Imagine watching a video and feeling like you're right there in the scene, surrounded by realistic sounds.
That's the dream.
They combine face detection, depth estimation, and spatial audio techniques to process the sound so it matches the visual layout perfectly.
It's like stepping into another dimension.
They tested it out, and it actually makes the audio and video much more consistent compared to the other methods out there.
This could really change filmmaking, gaming, virtual reality. The possibilities are endless.
Absolutely. It's a whole new level of immersion and storytelling. It's amazing how these researchers just keep pushing the limits. From the tiniest details of our voices to the grand symphony of nature, it's just incredible.
We've covered so much ground already. Before we move on, I wanted to go back to that paper about synthetic speech detection. You mentioned the Shifty Speech benchmark. What exactly is in it?
They wanted to make it as tough as possible for these detectors. Different languages, accents, even different emotional tones in the speech.
So more realistic.
Exactly. They even included background noise, different recording environments, all kinds of microphones. They really wanted to mimic real life.
And you mentioned that sometimes training on less diverse data can actually be better. That's counterintuitive.
It is. You'd think more data would be better, but if you overload a model with every possible variation, it might miss those core differences between real and synthetic speech.
It's like trying to learn too many languages at once. You end up not really mastering any of them.
That's a great analogy. It's a balancing act. Now back to music for a second. We talked about token synth and creating new instruments. But if we're making sounds that have never been heard before, how do we even know what emotions they'll evoke?
That's a good question. It's like venturing into uncharted territory. I guess it comes down to psychoacoustics, how we perceive sound.
Exactly. Our personal memories, our cultural background, even our physiology, it all plays a role.
So one sound could make someone feel joy, while another person might feel uneasy.
Absolutely. And that's what makes creating new instruments so fascinating. It's a blank slate for our brains.
It challenges composers and musicians to use these new sounds in a way that evokes specific emotions. It's like a whole new world of musical expression.
It is. And these synthetic sounds, they could be used for more than just music. Think about sound design for movies, video games.
We could create sounds that evoke a sense of awe, wonder, fear, like we've never experienced before.
Exactly. It's a whole new level of immersion. Now let's go back to that nocturnal bird migration dataset. What were some of the challenges they faced in creating that massive collection of bird calls?
Yeah, it's impressive. But recording in the wild can't be easy.
It's tough. The biggest challenge, the sheer amount of data. Recordings from all over Europe, each one could be hours long.
And it's not just about collecting it. They had to annotate every single recording, identifying those bird calls amidst all that other noise.
It's a huge task. It requires expertise and a really good ear. Those citizen scientists, they're the real heroes here.
They really are. And filtering out all that background noise, that must have been tough.
Imagine trying to find a needle in a haystack of sound. They had to use a mix of signal processing techniques and machine learning algorithms to isolate those bird calls.
It's a real testament to the power of collaboration. Humans and technology working together. Now, MT2KD, that general-purpose encoder, where do you think it could have the biggest impact?
Well, for me, it's accessibility, especially for people with speech impairments. Imagine devices that can understand a much wider range of voices.
That would be amazing.
Right now, speech recognition systems really struggle with anything that deviates from standard pronunciation. MT2KD, with its ability to handle all those different speech and audio tasks, it could change the game.
It could give people who have been excluded from the digital world because of communication barriers a real chance to participate.
Exactly. And it's not just about human speech either. What if our devices could understand all sorts of sounds in our environment?
Smart homes that can hear a broken window or a smoke alarm. That would be amazing.
Workplaces that adjust the lighting and sound levels based on the acoustic environment.
The possibilities are endless. As technology like MT2KD advances, sound will become even more integrated into our lives.
I agree. Speaking of which, continuous autoregressive modeling for speech synthesis, it sounds like a real breakthrough in creating more human-like synthetic speech.
It does. What makes this approach so promising?
Traditional methods, they kind of chop up speech into these individual units and then try to put them back together. It often ends up sounding robotic.
It just doesn't sound natural.
Exactly, but this new approach, it treats speech as a continuous stream of information, just like we experience it.
So they're teaching AI to speak more like us.
You got it. They're using continuous speech representations to capture those subtle nuances and variations in our voices.
And this stochastic monotonic alignment technique, what does that do?
Think of it like a conductor who keeps an orchestra in sync. It helps make sure the synthesized speech flows smoothly without any awkward pauses or jumps between words.
So it's about making synthetic speech not only sound human-like, but also feel natural. And it sounds like they've had some success with this.
They have. Their model actually outperformed the Valley model. And you know what's even cooler? They did it using way fewer parameters.
So more efficient, too. That's incredible. But as this technology gets better, it's going to get harder to tell real speech from synthetic speech, right?
That's the big challenge. And that's why research like the Shifty Speech benchmark is so important.
So what did they learn from all that testing?
Well, they found that some detectors are really good at catching synthetic speech made with certain parameters, but they struggle with others.
So there's no magic bullet.
Not yet. It's a cat and mouse game, really. As the technology for generating synthetic speech gets better, we need to keep improving our detection methods.
It's essential for maintaining trust and preventing deception. Now let's talk about visual-based spatial audio generation. It sounds like something out of a sci-fi movie.
It's pretty close. Imagine watching a video and feeling completely immersed in the scene with sounds coming from all around you.
It's like stepping into another world.
Right. This system analyzes the video to figure out where everything is and how it's moving. Then it uses that information to create a spatial audio track that perfectly matches what you see.
It's about creating this perfect fusion of sound and vision.
Exactly. And their tests showed that it really does improve the consistency between the audio and video. It's not just about making it sound good, it's about making it sound real.
It could revolutionize filmmaking, gaming, VR.
Absolutely. It's a whole new level of storytelling.
Now, before we wrap things up, I wanted to circle back to the Chinese dysarthria speech database. It's a massive collection of data, but how can we use it to actually help people?
This database has the potential to change the lives of people with dysarthria. It gives researchers a powerful tool to develop speech recognition systems that are specifically designed for their needs.
Systems that can actually understand them.
Exactly. It's about making technology more inclusive, recognizing that not everyone speaks in the same way.
And it could help us learn more about human language and cognition in the process.
It's a great example of how technology can be used for good. Wow, we've really explored some fascinating territory in this deep dive. From the intricacies of the human voice to the symphony of nature's sounds, it's been an incredible journey through the world of sound and computing.
It is amazing how researchers are constantly pushing those boundaries, using sound and AI in healthcare, entertainment, even our understanding of the world around us. It's really inspiring.
It is, but like with any powerful technology, we have to consider the ethics. Manipulating sound, especially now with this hyper-realistic synthetic speech, that's a whole other ballgame.
You're right, we can't just get caught up in the excitement of what's possible. We have to think about the potential for misuse, creating a synthetic voice that's indistinguishable from a real person that raises some serious questions about deception and manipulation.
Imagine a world where you can't even tell if you're talking to a real person anymore. It really underscores how important transparency and accountability are when we're developing these technologies.
We need to have open and honest conversations about the risks and make sure there are clear guidelines for ethical use.
Absolutely. And beyond just preventing misuse, we need to make sure these innovations are accessible to everyone. We have to be aware of potential biases in these systems and work towards creating inclusive technologies.
It's about making sure these tools empower people, not create new inequalities.
Exactly. And that brings us to one of the most inspiring themes that came up in these articles, using sound and AI to make the world a more inclusive place.
The work they're doing to create speech recognition systems that can understand a wider range of voices, especially for those with dysarthria, that's a game changer.
Imagine a world where everyone, regardless of their speech abilities, can communicate with technology using their voice. It would really level the playing field.
It's not just about improving accessibility either. Studying dysarthric speech and other diverse forms of communication that can help us learn so much more about human language.
It's a great example of how pursuing technological innovation can lead us to a deeper understanding of ourselves.
It has been an amazing experience exploring these cutting-edge advancements. I'm walking away with a sense of awe and excitement for the future, but also a responsibility to make sure these technologies are used ethically and equitably.
I couldn't agree more. Technology is a powerful tool. It's up to us to make sure it benefits humanity.
And to all our listeners out there, we encourage you to dive deeper into these topics. We've included links to all the papers in the show notes.
Go explore the world of sound and see what amazing things are happening.
Until next time, keep listening, keep exploring, and keep wondering.
See you then, T22.